Our second presenter today is Professor René Horsleben Petersen from the Copenhagen University Hospital in Denmark. He is thoracic surgeon, he is expert in robotic thoracic surgery, and therefore he is fully qualified to provide a strong message, strong voice against robots in thoracic surgery. Welcome.
Thank you very much for this kind introduction. My task today is to say no to robotics in the theaters. Can you see my slides?
Yes.
And can you hear me clearly? Okay,
yes.
Thank you very much. So these are my disclosures. I've been a proctor and teacher in VATS for many years, and this has been together with Medtronic, so that's my disclosure. So the aim of today's talk is to discuss advantages and disadvantages of robotic-assisted thoracoscopic surgery, and to demonstrate advantages of VATS, to discuss the potential for robotic systems in the near future. This is the experience of VATS lobectomies in Copenhagen since the very first one in 1999. We are approaching 3,500 VATS lobectomies, which is the largest series in Europe. As you can see, last year we did 341 VATS lobectomies, and there were 4 conversions. You can see conversions is the red one on this slide, and this is between 1 and 1.5% for the last 6 to 7 years. We are performing VATS for 90% of all lung cancer cases in Copenhagen, and we do not get selected cases. These are from the geographical area belonging to Copenhagen. And this is just to show you where we come from. So if you look at the Oxford Advanced Learners Dictionary, what is actually a robot? A robot is a machine that can perform complicated series of tasks by itself. So it requires automaticity. I just want to remind you there are no systems currently that are automatic. They are mainly computer-based systems, so it's computer-assisted surgery we're talking about, not really robots. But I'll come back to that. This is the most recent review listing the advantages and the disadvantages of the robotic systems. So the advantages are 3D visualization, better ergonometric, a better lymph node dissection, better feasibility of advanced resections, and a shorter learning curve. And some of the disadvantages mentioned is higher cost, longer in-theater operating time. You need a skilled assistant at the table in case of conversion. If there's a bleeding, the surgeon's unscrubbed, and you need someone who can interfere immediately to handle the bleeding complication. There's a lack of tactile feedback, and currently the number and the size of the ports are down to 8 millimeters, and most robotic surgeons are using 4 incisions for lobectomy. So to deal with the 3D thoracoscope, we have now 3D thoracoscopes in our theaters. I use it every day. So the argument that you have better visualization in the robot, I don't think it exists anymore. I believe and I agree with robotic surgeons that 3D really can make a difference, especially in advanced resections. So how about advanced instrumentation? This has been a clear lack in the robotic systems, mainly driven by financial issues, that the stapler was introduced very late in robotic systems, and the advanced energy systems are not up to the standard of advanced systems we have for VATS. For instance, this is the newly thoracic ligature with a nanocoating, which I use for especially for lymph node dissections, but for mainly the whole procedure of VATS. We have electronic staplers like the Signia stapler, which measure the pressure of the tissue and guides you in choosing the right cartilage. And if the tissue is thicker, it slows down to bend the stapes appropriately. How about ergonomics? I definitely agree. It seems a lot more comfortable to be sitting in a chair, and I must agree, this is more comfortable for the surgeon with the robotic systems. So now a video is playing of a lymph node dissection in a right lower lobe tumor within one disease, and as you can see, I hope you can see the video. Can you do that? You see it?
No.
You are.
Can you see it in the studio?
Yes.
You see it. Okay. So you can see there's a complete clearance of the subcarinal area, all the stations 7, 8, 9. And as we turn to the superior mediastinum below the azygous vein, there's a complete clearance of all the lymph nodes in the superior mediastinum, including the stations 2 and 4. A bit of fatty tissue is left where the recurrent nerve is swinging around the subclavian artery. And this is a full lymph node dissection. All the lymph nodes, all the fatty tissue is removed. I think lymph node dissection is up to the skill of the surgeon and the attitude of the surgeon, whether you believe in a systematic lymph node dissection or not. It may be easier with one tool than another, but it is possible with VATS as it is with robotics. So I do not believe that's an argument for robotics. How about advanced resections? We saw that sleeve resection is possible, and I know from other surgeons doing VATS, sleeve resections and robotic sleeve resections, they definitely find it easier to do the robotic sleeve resection, but the feasibility of VATS sleeve resection has definitely been proven by Diego Gonzalez Rivas, who's done a large number of single and double sleeves and with just one port, just a uniportal VATS. So I don't think that's another argument for the robotics. So how about the learning curve? Well, I think when you look at the learning curve for someone who's done VATS and then shifts to do robotics, you must take into account that there's been a long learning curve to do VATS, and then you benefit from that in your robotic experience. But I do believe that many surgeons coming from open surgery find it easier to do robotic surgery. And in this paper, you can see that the learning curve or the learning time was estimated to 32 operation, which is shorter than the traditional 50 we consider for VATS. So there may be an argument, and especially for open surgeons, I think it seems like easier to turn to robotics, and this could be a good argument, of course. This is, I hope you can see the video again. This is how I do thymectomies. I use 5mm ports and CO2. So the ports are smaller, less invasive than the ports currently in robotic systems. I know that there will probably be 5mm ports for robotic systems in the near future, but this is just to show that you can actually get a very good access to the mediastinum by VATS. Has the video finished? Okay, I'll move on. So this is the most recent meta-analysis comparing robots to VATS, and the aim for this meta-analysis was actually the question that we are asking today. Is there any advance in changing from the traditional VATS to a robotic system? And this was the Da Vinci one. They looked at 14 retrospective studies, and I must say this is the standard. Most of these studies are retrospective studies, and they could not find any statistical significant difference in respect to conversion, lymph nodes numbers, hospitalization time, duration of surgery, drainage volume, prolonged air leak, and so on. And they conclude that there doesn't seem to be an advantage for an established VATS surgeon transitioning to robots. So this comes to my conclusion. So currently, I don't think you need a robot in my thoracic theater. But having said that, I believe in robotic systems. I believe in the future of robotic systems. I think there's a lot of potential, and I think that's where our field in thoracic surgery is developing in this direction, because we will have more possibilities to build on robotic systems. So as Julia mentioned, so there's a lot of development. So image fusion, 3D reconstruction fused with the actually thoracoscopic image. This is possible in robotic systems, and this may facilitate more advanced resections. We are moving towards more and more segmental resections. The Firefly system is part of the robotic system, but we have now the Elevision for VATS, so we can also use ICG for intersegmental fissures, but still the potential for robotics is big. Artificial intelligence and big data storage will probably in the future make these systems able to use automaticity based on the big data and AI. So I think that in that case, we'll be moving to real robotics. Hopefully the more advanced energy systems and advanced stablers will be built into these robotics. It's all about innovation, but it's also about competition. And there has been one robotic company on the market for many years. And in the last couple of years, there has been 8 to 10 other systems FDA approved. So we now have many players on the robotic market. And I think that's really what we need. We need the big companies to invest in this because there's a huge potential. So this concludes my talk very much. And thank you very much for your attention. These are the references.
Thank you very much. Dear Julia, dear René. These were quite efficient plaidoyers and